Greeting to one and all. I am S. Ramanakumar Joga. I am here to present my paper ID 1570832246 and my title is PQD's detection and classification under normal and noisy conditions based on RADWT and SVM based technique. And I am from School of Electrical Engineering, Kalinga Institute of Industrial Technology, Bhubaneswar, India. So these are my contents in my PPT. So coming to introduction, according to IEEE, power quality is defined as concept of powering and grounding electronic equipment in a manner that is suitable to the operation of that equipment and compatible with the supply system and other connected equipment. In general, power quality is defined as it is the ability of a power grid to supply power to the consumers efficiently, and it also expresses the ability of an equipment to consume the power being supplied to it. So there are some power quality issues are there, and there are like light blinking, sudden equipment maloperation, sudden tripping of circuit breakers, premature equipment failure, poor performance and unexpected shutdowns, lost data in electronics, capacitor bank failure, high ground current, and others. So, these symptoms of power quality issues are due to some power quality disturbances. So, these power quality disturbances are like voltage sags, voltage swell, momentary interruptions, transients, harmonic distortions, notches, voltage fluctuations, frequency deviation. So it is now very important that an engineer or researcher to detect and classify these power quality disturbances and also should constantly monitor the voltage and current value in the distribution system. So by keeping monitoring the voltage and current value, they know what disturbance occurring in the system. So in general, in our industry, in our application, we are using power quality analyzers. So these analyzers are working on applications like RMS current and RMS voltage calculations. But in our paper, we presented a proposed method by using signal processing technique and machine learning technique. So we have done some literature review for proposing a method. In the first paper, we have studied about the deep learning based method for the robust and efficient fault diagnosis in the electrical power system. So in this, they have users for CNN technique to detect the different types of faults that occur in the power system. In the second paper, we have taken a novel label guided attention method for multi-label classification of multi-power quality disturbances. So it is published in IEEE Transactions on Industrial Informatics. So in this paper, uh, they have took a convolution neural networks and they extracted the features of the PQD signals and they labeled and they used the neural network models and they categorized the different types of PQDs in the distribution system. So problem formulation. So what we have done is we have different types of power quality disturbances like normal sine wave, sag, swell, interruptions, harmonics, sag, harmonics, swell, harmonics, flickers, and oscillatory transients. So we have formulated in mathematical equations. So you can see the table. So we have formulated the power quality disturbances in the mathematical equations. So proposed methodology. So proposed methodology, we have first we have to formulate the power quality disturbances like sag, swell, harmonics, flickers, transient interruptions. Later, these PQD signals are decomposed through rational dilation wavelet transform. So after decomposing these signals again divide into the various frequency components. So these frequency components are taken as input to the uh, machine learning classifier. So we are considering here support vector mission classifier. So this is the proposed methodology flow chart. Coming to the what is rational dilation wavelet transform. So rational dilate wavelet transform is implemented using self-inverting FIR filter banks is approximate shift invariant and can provide a dense sampling of the time frequency plane. So, what is difference between the ordinary discrete Wheeler transform and RADWT? So, we can increase the value of quality factor here. So, in RADWT can attain high Q factors. The wavelet can be resembled as Gabor function and can hence have good concentration in the time frequency plane. They entirely depend upon the value of P, Q, and S. The quality factor depend upon these values. So support vector missions. So we already know we have support vector mission is a supervised machine learning classifier, and there are two types of support vector machine classifiers like linear SVM and non-linear SVM. In this paper, we are using both linear SVM and non-linear SVM techniques, and we will um, check which method is exactly working efficient to our proposed methodology to detect PQD disturbances. So for results and analysis discussions, we have two different types of power quality disturbances like sag harmonics, swell harmonics, and flicker signals, and we are decomposing those signals up to 11 levels by using rational dilation wavelet transform. So we consider some parameters like P is equal to 4 and quality factor is equal to 5 and S is equal to 1. So dilation factor is considered to be around 1.25 and redundancy factor is calculated as around 5. So you can see the figures here. So it is a rational dilation wavelet transform of the ordinary normal sine wave, and we have took for 11 levels. We have decomposed into 11 levels. For similarly, we have done to the sag and similarly we have done decomposition. You can see the figures here, interruption and harmonic sag with harmonics and swell with harmonics and flickers. So these are the different we have done. So after decomposing these PQD signals, these frequency components are collected as input data for performing the classification class task. The performance of classification task is evaluated through confusion matrix. So here we have done for both linear SVM and also for the kernel function SVMs or non-linear SVMs. So here we have given the scatter diagram here. You can see different colors here, uh, different types of PQDs here like flicker, interruption, sag harmonics, and with different colors. And this is the confusion matrix. We have took 4,000 input data of different PQDs, and we have classified the PQD. So the classification done by various kernel SVM function techniques and it tabulated table. Here we have took like linear SVM, Gaussian SVM, polynomial SVM, and sigmoid SVM and RBFM. In this linear SVM with RADWT is the effective version with effective method with 98.50 classification accuracy. The proposed method is also validated for PQD signals under noisy conditions. So we introduce a noisy signal by giving this formula to the normal. Uh, so you can see the diagram here. The normal signal with sag disturbance with we have to two conditions here. One is 25 dB SNR and 10 dB SNR, and again we have calculated the classification accuracy. Here also we got Gaussian SVM performing well better than the other kernel functions. Like 98% we got for 25 dB and 96.50 for 10 dB. Similarly, we have compared our method to the other methods which are existed in literature, and our method is performed very accurately with 98.5. So these are my conclusions. The Gaussian kernel SVM based classifier performed better with rational dilation wavelet transform in classifying power quality events. And the second conclusion is the RADWT enhances the performance of signal analysis compared to the conventional discrete wavelet transform based methods. The multi-resolution analysis and tuning of Q factor added advantage of this proposed methodology. It is also concluded that proposed method is outperformed existed methods in classification accuracy and also computationally efficient, which we have seen in before uh, slide. So the last one, the proposed method is also tested under various noisy conditions and found to be proposed method yield better results for both normal and noisy condition.